Oh my gosh, is chat no longer a feature?
I just got a chat. So chat is still.
Sorry.
I think you need a different window when you have Zoom open in full screen. So, debugging session number 1, chat shows up not in the right-hand side panel, but as a small button down in the lower center when screen is full, which happens when someone is presenting screen unless you minimize the screen.
I just posted a link, polev.com/KevinGJamison690. We're going to try some interactive techniques.
Also, it also reads as Kevin G. Jamies, which fun fact, they chose us to teach these courses together because of our name overlap.
That's exactly right.
That's right. Those are the only 2 reasons. That's the only reason. We had good name overlap, so they could make things like this poll everywhere link shorter. Oh man, 205 participants.
Oh man, I feel like people are not very accurate with their with where they're, unless people are, a lot of people are in the Midwest and Rocky Mountains.
What do you mean? Oh, you already sent it. Oh, I see.
Oh, can you not see the results?
No, I just hadn't clicked on it yet. That's fine.
And then I will.
Oh, I'm not sure if I can see the results.
All right, it looks like a lot of US, India, Turkey, China.
I can't see the results, by the way, Kevin, or at least
it should be. I think I'm sharing the screen now.
Yes, good. Well, we got some more. Wait, is someone in Alaska? Okay, we're getting some more ridiculous ones. So we got a question about whether we prefer people to have their video on. It's certainly nicer to have some people with video on so we don't feel like we're lecturing to a blank room, but we understand it's sort of difficult. It's an unusual time, so we're not going to require it, I don't think, this time.
Someone just asked where are the slides privately to me. That's a really good point. In the future, we will have slides publicly available. They'll be posted to the website before lecture, and so you can follow along with the slides if you'd like.
We'll also be posting annotated slides after lecture.
Yeah, we're going to plan on basically doing an iPad sort of thing where we'll have slides and we'll write on top of them. And so we'll try to post slides before lecture and the annotated slides afterwards. Yes, the video will be published. It is recorded right now, and it will be available for anyone later because we understand that not everyone can connect at every time, and some of you are in very different time zones.
Very different time zones, or in places where your internet is far from reliable. So we want to make sure that you have the ability to, for example, go to a Starbucks or somewhere that has better internet than where you may be able to be at the time of lecture. So.
Okay, it seems like the number of participants has settled a little bit. So I guess we'll go ahead and get started. So welcome everyone to CSE546 and 446. If you're a little confused to see 2 numbers here, and if you're just register for 446 or 546, and you know what these two numbers are for. That'll become obvious in a few moments. But before then, just want to sort of start off the class with just a really basic overview of machine learning before we get to the boring logistics of the course.
Before we do that, maybe we could introduce ourselves.
Oh, yes, that's a good thing.
Yeah.
I'm Kevin Jameson. I'm a professor here, assistant professor in computer science, and I work on machine learning and interactive machine learning, typically, where there's a sort of a back and forth between human and machine. Jamie?
Yeah, great. I'm Jamie Morgenstern. I'm also an assistant professor in computer science. I also work on machine learning with an emphasis on understanding what's now referred to, I guess, as the burgeoning field of fairness in machine learning, but in general, trying to understand when we're using these machine learning algorithms that we'll talk about in a minute in settings where they're actually making choices about humans, why those predictions are so different for people with different demographic backgrounds.
Great. And we'll have a number of opportunities to ask questions and fill in. And today's lecture is going to be, just really basic logistics and things like that. And so we'll have plenty of time at the end and during to answer any questions you have about the course or about us. We're just happy to make this as painless and as seamless as possible. Although we do anticipate quite a few bumps along the road, making this a virtual course. But I hope you'll bear with us, and we'll try to do our best. And also, so just right off the bat, I have a slide on this later, but how it's going to work is we are in Zoom. Obviously, welcome, you've all made it. And how we're going to, general Zoom etiquette is probably worth discussing. And right up front. And so as we got kind of already discussed, please mute yourself when you're not speaking. We do want to hear you though. And we would like you see your video as much as possible. It's nice to be able to have some feedback when you're lecturing, to see people nodding or shaking their heads or looking confused. It's a lot easier than seeing a blank sort of screen. It allows the class to go a little bit more smoothly and allows us to do our job a little better. All lecture section office hours are all going to be on Zoom. All links will be on Canvas to these different things. We will deal with the logistics of that a little bit more later in the lecture. That's how it's going to be. But just I wanted to get to questions. So now that we're in Zoom, there's a chat feature in Zoom. I'm not sure exactly how yours looks like, but there's a little more button with 3 dots, and then you can hit chat there, and they can bring up the chat window. When you want to ask a question at any time, please, you can either type your question out there, or you can just type hand, and there is a Zoom conductor, one of our TAs, that will interrupt me or Jamie and say, hey, Alice has a question. And so then I would have you then ask your question directly to the class and me. So either way works. The TA will interrupt me while I'm lecturing because it's a little tough to see the screen and the chat and the video all at the same time. And please don't use the Zoom's raise hand feature just because it doesn't track the ordering in which questions are asked. And so again, just either if you have a question, either type directly into the chat window, and the TA will basically decide whether they can answer that question just directly real quick, or if they want to, or they'll interrupt Jamie or I, and we'll take it online. Otherwise, if you just want to type hand, then we'll call on you there. Okay.
Also, please feel free to use the chat for anything that's happening that's like sort of, if our video freezes or something else, like feel free to try to let us know that way. We know that there will be numerous technical difficulties throughout the course. So
we're trying to make it as smooth as possible, but we're realistic. Okay. So Jamie and I just want to start this lecture just by giving you a brief overview of machine learning, what it is, why we're excited about it, and before jumping in the logistics of how we're going to run this course, and hopefully how we're going to get things going. So as sort of a very silly sort of example, let's contrast machine learning with a traditional program, a traditional algorithm. So suppose that you want to go on Twitter and categorize all tweets on Twitter as either relating to cats or dogs, right? Because it appears that there's some evidence. We always believe that cats are more popular than dogs on the internet. Cat videos and such. But like maybe there's some evidence that dogs are more popular. So it's not super clear. So let's try to categorize every tweet on Twitter that's having to do with cats or dogs and seeing which one's more popular. Okay, we're trying to count how many tweets have to do with cats, how many tweets have to do with dogs. And so how we would do that is we'd have to write a program that sorts tweets into those containing cat, dog, or other, meaning it doesn't mention cat or dog. And so in this traditional program that you take in any programming course, you'd maybe set up 3 containers of cats, dogs, and other. You'd loop over all possible tweets on Twitter. You'd do a string search of is cat contained in the tweet? If so, add that tweet to the cats list. If dog is in the tweet, add it to the dog list or other. And for simplicity, I'm assuming these are mutually exclusive for this example. And so then that would, basically you'd have these 3 lists. Then you can just count if there's more cat or dog things on Twitter. But where things get a little tricky is if you want to do a slightly more interesting task. So suppose there's, consider all images on Google image search. And suppose you wanted to sort these images into all those that contain birds, airplanes, or other. Okay, so you consider all possible images. Some of them contain birds, some of them contain airplanes, and then some of them contain other stuff like cars and stuff. And we just want to see how many are birds or airplanes more popular. And so we'd like to do sort of the same thing as what we did for the tweet thing. And so we'd start with this program. Say, okay, sort just loop over all possible images on Google image search. If bird is in the image, append that image. If plane is in the image, append that image to the plane list and other. The issue is that those blue lines there, if bird is in the image, determining whether if a bird is in an image or if a plane is an image is actually a super non-trivial task. It's not as simple as just doing a string search and is the word CAT inside some text search. Any one of us can write that program up. But writing up a program to determine if a bird is contained inside of an image could be really hard. It's totally non-trivial how you would actually do that, what features you'd pay attention to. So one way that machine learning tries to think about this is we extract something called features from these images, and these are just attributes of the image. This could be anything from does this image, what is the amount of red content in this image? What is the amount of blue content in this image? In the top left corner, how much, what's the overall sort of contrast look like? What's the brightness look like? And we can extract all these different features, thousands and thousands of different features. And so we can get basically a vector representation of each image. So what I have here is just 2 dimensions. It would be many, many dimensions, but just for representation's sake, if we just have 2 dimensions here, each black dot represents a single image. So each black dot here is its location in this space represents, maybe the amount of red or the amount of blue in this image. And then points that are closer to each other are more similar to each other. So you'd expect that points that are close, if one image is of a yellow car, its nearest neighbor, the point that is closest to that point, would also be maybe like a yellow car, or a yellow school bus, or something like that. And then once we have all these images, we can actually have humans go and annotate them. They can look at these images and tell us, yes, this is an airplane, this is a bird, or this is something else. This is a task. And so we would get some label information for these images. So let's say we all planes are labeled red, all birds are labeled green and other are labeled blue. And maybe we didn't label the entire data set, and the fact that not all of them are colored denotes this fact. The fact that some of them are black means that we only observe labels for a subset of all possible images. Now, once we have this subset of the images labeled as bird, airplane, or other, we can then train a classifier rule. We then learn some rule, this purple sort of boundary, where just given this finite amount of data, we don't know the labels of the black labels, but we can sort of draw some regions. We can sort of draw some regions, squint your eyes, and maybe it looks like this. And what we call this is a decision rule, where you have on each sort of region where it's tinted blue, we're going to say that is all class labeled blue. I'm going to predict for each black dot in that region as labeled blue. For each black dot in the green region, I'm going to label green, and so forth. And what that allows us to do is, given a very small subset of the data set labeled, we can then predict what the labels of the other images are without ever actually asking a human to label them. And then this is how machine learning is really working. And to summarize, so with the cat example, the decision rule was hard-coded by an expert. As a human, we thought hard. We thought, if I wanted to detect if a cat is inside the tweet, I'm going to write a program that will do a string search for is cat included in the tweet, and then just count them up. The difference between that and machine learning is that the actual decision rule is not coded up by an expert human. It's actually learned from the data itself. We got some small subset of the data labeled, and then from that, we learned a decision rule, which is this T sort of thing, these blue region, green region, red region. We learned that decision rule from the data, and then we applied that decision rule to all images on Google image search. And so the difference between a traditional program and machine learning is really that we are using data to write the program in some sense. And we'll see this over and over, a number of different examples of this going forward.
Yeah, great. So just to reiterate, machine learning has some fundamentally different structure than sort of these hard-coded programs that you might write to make decisions. In general, they rely on data, which we call any number of different things, but historically, generally what we mean when we say data is that there are some past observations we're going to use to develop the way we're going to be making decisions, right? For example, in the case of what Kevin was just describing, this collection of images that were labeled as cats or dogs, airplanes or cars. And then that information is going to be used in some kind of automated way to make some prediction about new pictures or new examples that we haven't seen labeled before, right? And generally, to make this work, the way this generally operates is that we're looking for some kind of pattern, right? So the example of there being yellow in some of the images, and that may be suggesting that there may be a school bus in the picture. That might be some hypothesis, right? The simple hypothesis saying if there is at least this much yellow in an image, label car, right? That would be a hypothesis. And in general, we might be looking at a class of models, which might be the set of all statements that say if color in some simple RGB greater than 50%, then label something, right? We might be looking at some collection of decision rules that look like that and selecting amongst them based on our historical data. Right? And then in general, when we have some images that come up on Google image search, we might be looking to actually apply that model to actually guess whether these new examples contain a car or a school bus or something else, okay? And a useful thing to note in all of these cases is both in the case when you have a hard-coded program that looks for the string lowercase cat, lowercase dog, or when you've written a hard-coded program that says if there are at least 30% of the pixels in this image are yellow, predict car. Both of those will have settings where humans understand either the tweet contains something about a cat or a dog, or the image contains a car, but those decision rules, those programs won't necessarily say that's the case. Go ahead, Kevin. Yeah, sorry, we're working on the logistics of sharing screens, right? Okay, so we gave a sort of toy example of this idea that like maybe we would want to guess whether an image has a picture of a car or not, but machine learning is actually much broader than deciding what images on Google image search should come up when you type cat or dog. In fact, Google machine learning is being used to make all sorts of predictions sort of everywhere around you. For example, many of you are using various services now more than you probably ever have before in your life, be they Netflix, Spotify, or other media services. And they're trying to predict, based on what you've watched and how you've rated it, what you might like in the future, right? And they're using various forms of machine learning methodology to do that, and hopefully provide you with a better viewing experience while you may be at home a little bit more than usual. Amazon is making decisions both in terms of what to recommend you might buy in this time, and also using machine learning based on how many people are trying to afford hand sanitizer to jack up the price on that. I think they've stopped that at this point. We're also using machine learning and various other statistical techniques when designing treatment for all kinds of medical things. And we'll talk more about certain examples of that throughout the course. Many credit agencies and credit card companies and banks decide what kinds of credit cards are available to you, what kinds of loans are available to you, based on historical data about people who have similar credit histories to you. Oh, that's a self-driving car. Okay, good. I was like, what? Okay, so we're also, in a world where we're developing technology to automate a bunch of jobs we have historically thought humans would be doing, like driving cars. Also, many examples in settings where you wouldn't expect machine learning to be making so many predictions, like in the context of agriculture. Okay, so machine learning comes in many flavors, but three primary flavors, each of which we'll talk a little bit about. Throughout the course. The first, which we will talk about first in the course, is this idea that machine learning might be used to predict continuous values, right? So maybe some of you have joined this class with the hope of gaming the stock market, right? Trying to predict what the Dow Jones is going to do from hour to hour, minute to minute, based on news trends, based on the historical behavior, the recent historical behavior of the New York Stock Exchange or the New York Times. You might be trying to predict. I think actually credit scores might be real, might not be real value, but you might be trying to predict what the average temperature in Seattle, Washington is going to be tomorrow at 11 a.m. Based on various other things. You might be trying to predict the average Netflix rating that some collection of users will give some new piece of content based on some collection of features that they might present with. And in this case, right, basically you have a bunch of different information about individuals or about something you're trying to predict. And based on that historical information, you're trying to predict something real value, right? So you're not just saying yes or no, you're not just saying cat or dog, you're actually saying, this is some like finer grained piece of information about that. Right? And that presents its own set of challenges above and beyond, in some ways, the other things we'll talk about. Another set of machine learning tasks belong in this setting that we talked about at the beginning, this idea that we might want to predict some kind of categorical value, right? We want to predict whether there's a cat or dog in this image. We want to predict whether a piece of mail is spam or not, whether a particular patient has a certain kind of condition or not, whether or not someone will repay a loan. Again, I might argue that that's like sort of in the opposite way as credit scores, perhaps not quite as categorical as whether someone will repay a loan or not. Right, so in this case, right, usually you're trying to make a hard decision, yes or no, cat or dog, and that has, again, some mathematical opportunities and challenges that the real valued outcome decisions may be somewhat different from. And finally, in some section of the class, we'll talk about using machine learning methodology to predict structure in a collection of data, right? So this is a very broad class of things that we'll be placing into this category, but you might want to try to understand sort of the ancestry of many different kinds of species based on the genetic sequencing of some of them, right? And that might even include looking for, ancestors that you don't actually have in your current collection, right? You might be asking, hey, I have, 100 million images. I want to categorize them in some way such that like the groupings that I have all have some similarity to one another, right? You may also have some complex social network where you understand ties between different people, and you might want to ask, what are the communities that belong to this particular social network? You might also be asking, hey, I have a bunch of Twitter data and I want to know some trendy topics on Twitter, and not just using hashtags, but like actually saying, I'm trying to understand sort of the content or the relevant information, the general topic that these different tweets are referring to, right? And in this case, right, there's not exactly, the decision that you're trying to make or the prediction you're trying to make is sort of more nebulous in many ways than the previous set of predictions, right? It's not that there's some ground truth label that you necessarily can reference, or some ground truth, value that the stock exchange is going to have at 11 a.m. tomorrow. It's sort of looking for structure in a bunch of relatively unstructured data. Okay. Yes. Also, so all of this involves a mix of statistics and theory and practice, right? So it's useful to keep in mind that all of this has a lot of theoretical underpinning. There's a lot of algorithmic understanding. There's a lot of statistics to understand when these things will work and when they won't, when things are possible and when they're impossible. And also lots of empirical evidence that sort of suggests when you ought to and not to do different things. Okay.
And?
Yep, sorry.
I think Barrage, is that?
Yeah. So I just wanted to ask a quick question about so something that you said before about like we talked about hard coded versus like learning from data. So it seems to me like when you could predict in the string it is you look at it's his cat or his dog, right? So you have like a really nice representation that you can just check easily. So in the case of image, if you could have some kind of like really universal representation for images, and and if you could check it, right? So then you could probably like boil that down to a hard-coded rule, right? If you had a nice representation that you could easily check, right? Is that the right way to think about it?
Yeah, so I guess a simple, one way to rephrase your question, and tell me if you don't agree with this rephrasing, is that the string CAT is universally agreed to represent cat in strings. Whereas there is no sort of quick, easy description of what always means a cat in an image. And if we had such a thing, and if we could sort of write down a simple description of when a cat is in an image that we could sort of program, that we could like explain to some computer, we could do that as opposed to from data. But machine learning is trying to find such a thing, right? Essentially, from a bunch of examples of images that contain cats or that humans say contain cats, machine learning generally tries to find some simple description, kind of like CAT, the string, from the perspective of like a JPEG file.
Right. Okay. Thank you.
Yeah, absolutely. Okay. So what slide is this, Kevin? Is this where we share, or is this me still?
I can take it.
Great.
So this is an overview. You're here, you made it. So lectures here Monday, Wednesday, 9 to 10:20. Your instructors are myself, Kevin Jameson, and Jamie Morgenstern. We're professors in computer science. The course website is listed there. If you're in 546 and wondering where is my website, this is the website. I only realized a few minutes ago that I never actually pushed an update to forward from 546 website to the 446 link. I will do that immediately after the lecture. So it'll just bounce right to there. But for the course website, there will be one course website for 446 and 546. And this will be the website. And so, what is this class? What will we be learning? Jamie and I just gave an overview of the kind of ideas at an extremely high level. To get some key terms that you might hear, we're really interested in the goal of my class, or of this class, is really to give you the fundamentals of machine learning and make you useful. So we're going to learn concepts mostly. We're going to really emphasize the conceptual parts of machine learning over the nitty-gritty details of the methods. Those we will go into detail on some particular methods because they're so generalizable. Learning the nitty-gritty details allows you to do more things and understand more concepts later. And so we will spend, say, for instance, quite a bit of time on linear models because they're so fundamental and useful for understanding more complicated concepts later. But we're going to go over things like bias variance trade-off, overfitting, optimization, in these computational trade-offs, statistical and computational trade-offs. There is a trade-off there. The concepts of supervised learning, where these are you have some feature information and a label, which could be either cat or dog, or it could be the temperature, and you're trying to predict the temperature from feature information, or unsupervised learning, which was this structure prediction problem, where you're just given some features and you're trying to make sense of it. You're trying to get some sort of information out of it. And so these are sort of the main concepts that we'll cover, and we will go through specific models in our pursuit of understanding these basic concepts. And so, it's impossible to teach you every model out there. We are not going to, that is not our goal. We are not trying to give you the state-of-the-art sort of models. We're trying to get you to a point where you yourself can learn these other models. We're trying to give you the concepts and the background knowledge so that you can go and read a paper or read even, if a chapter of a book somewhere and pick it up really quickly. Because if we taught you the latest and greatest right now, it would be out of date next month. Basically, it's just a very, very fast moving field. And so to keep up with it, it's best to know the fundamentals. And then once given the fundamentals, it's a lifelong learning sort of situation. And so because of that, this course is not a survey course. We are not going to give you a laundry list of algorithms or how to win Kaggle competitions. We will give you basic tools that will be useful for these things, and the homeworks will demonstrate how to use these tools in a very applied way and how to use them. But it will not be sort of case-based in the sense of we're trying to really try everything we can, trying to get from 98% accuracy to 99% accuracy. The class really will be based on fundamentals and overall concepts, but we will have some homework assignments where you will actually try to really sort of grind it out and try to get the best possible performance, which is really what is valued in industry. It's also, I just want to warn you and be very upfront about this. This is not going to be an easy course. This is not a course that you're taking for fun and, sometimes doing the homework and, maybe not doing the reading sort of thing. We really expect you to come into this course right now to have familiarity and maturity with linear algebra and probability. And we have, we'll talk about this a little bit later, but we have a homework assignment due next Wednesday that will sort of test your skills. You should use as a barometer for your skills. I don't want to mean to scare you, but this is not going to be a very easy course. It's traditionally seen as a very difficult course. And basically, the more you are prepared with these prerequisites, we looked at the final exams of all the prerequisites, and basically, if you could have gotten a B on those finals today, then like you will be fine in this course. And so that's sort of what we're expecting coming into this course. And if you have that background, you will do fine, and we will be going at a pace that you will be able to keep up. But if you do not have these prerequisites, it will be a very time-consuming and difficult course. The homework will also be pretty time-consuming because there are no exams. Please allocate your time appropriately.
Yeah, right. So our prerequisite list, and apologies for, I'm perhaps less familiar with some of these than some of you, not the material, but the partitioning of the material. But in UW CS language, right? Math 126, CSE 312, Math 308, Stat 390 are equivalent. Some equivalent courses, right? So if the words rank, linear equations, linear dependence, if those don't sound familiar to you, that should be a big red flag, right? All of those should be sort of easy, tucked under your arm, like part of your toolkit, ready to go. Multivariate calculus, right? Probability and statistics, right? So you should know what a distribution is. You should understand what a probability density is, what marginals are, what moments are. You should also have some basic understanding of algorithms, right? The primary goal of this course is not necessarily how to teach you to develop really novel algorithms for things, but you should have a general understanding of like algorithmic techniques, how data structures generally make things more efficient. You should be able to analyze whether an algorithm runs in like linear time or exponential time, right? Some of these things. The question, can I learn these topics concurrently? I think in general, we want to discourage you from thinking that you can learn all of these things at the same time as learning the material in our course. We're going to assume you have this material already from homework 0, right? Which is, you should start working on as soon as possible. It's due Wednesday. We want to encourage you to not start on it, to start on it as soon as possible. Right? We're not supposed to assign anything due this first week. This homework historically has been due Monday of second week. We're giving you until Wednesday. But the reason that we have homework 0 due so early is that we want to explain that we expect you to understand this background and these prerequisites as actual prerequisites, not co-requisites to the course. Okay?
Sorry, go. I just wanted to follow up and provide a little more context for can I learn these topics concurrently. This is my 4th time teaching this course, and I've had students try to learn these topics concurrently. And what I would really suggest here is saying for each prereq you're a little rusty on, or you're not, you couldn't walk into the final exam today and get a B. I would basically say that you should add 10 hours for every prereq, 10 hours per week for every prereq you do not have. And
the baseline's probably what, between 10 and 20 hours.
Right. Yeah. So I mean, like if you're very rusty on these prereqs, can you do this class while being rusty and catching up with these courses? Yes, you can do it. But I just want to set expectations that it's going to be a lot of work. Oh, I've worked with a lot of students. They've come to office hours every week, and they've made it through the course. And they said it was one of the most rewarding sort of experiences they've had in higher education. But they also said they worked their asses off. And it was a ton of time. And even with all that time, they still didn't end up with, a top grade or anything. So like, I guess what I want to say is, we gave out ad codes very, very liberally based on prerequisites. And so we just want you to self-select, be very honest with yourselves about homework 0. And judge for yourselves whether this course is appropriate.
Yes. And there's a question in the chat about whether learning Python concurrently is something that's possible. I think I want to say yes to that.
Yeah, I agree.
From my, assuming you have some programming background, right? Assuming you know how to program in some languages and are generally familiar with like asking Google for like, how do I like sort a list in Python, that sort of thing. If you feel comfortable, if you have like programming background, but you haven't programmed in Python, that should be fine, right? That will add some time up front, but we're not asking you to do like super complicated programming assignments, right? It'll require more that you understand algorithms and can then like translate to Google, like, how do I do this in Python kinds of things. Not like how do I solve my homework in Python, but basic questions about like data structures and things in Python. If you feel comfortable basically making that transition from a language to Python, then that should be doable concurrently.
And there's also a lot of resources on the web, or on the websites that are linked to. LearnPython.org is a great resource. There's also sort of things like, you should also search in Google for things like, personally, when I was an undergrad, I did Java and MATLAB. And for all my scientific computing, I used MATLAB. And there are tons of tutorials that are basically like, oh, MATLAB, this is how you translate all those things to Python and NumPy. And that's super useful. And the first week of section, which we'll get to in a bit, will be on a Python review and these sorts of things. So I totally agree with Jamie. I think if you don't know Python, that's not a problem. You will. It's very easy to pick up if you have any programming experience.
Yeah, and another question. Well, the question about whether homework should be whether it needs to be LaTeX it has been asked on the I think the short answer is yes. The slightly longer answer is if you don't know LaTeX, we won't be asking particularly complicated things in LaTeX, and we can talk about it. Definitely everything has to be typeset. It will be easier for you to typeset it in LaTeX than anything else. Come talk to us or your TAs if that's a significant problem.
Yeah, I mean, like I think in previous quarters there has been like 1 or 2 students out of the 200 that have tried to use, say, Microsoft Word to type up their solutions, and I think by homework 1, after homework 0, they switched over to LaTeX. LaTeX is just an amazingly powerful programming language to typeset mathematical equations. It will be rough at first, but you will love it once you are proficient in it. And you will never go back.
Proficient at it once you are proficient at it. Yeah. Also, we're being asked about providing a LaTeX template. I think we'll do that.
Yeah, we can do that. That's not a problem.
Yeah. Right.
Sorry, we're going a little bit out of order.
Kevin, I also have a couple of questions about the balance of proof. How much proof versus maybe applications on the mathematical side of the homework you would see, and also with the balance of programming versus math on the homeworks or in the course in general would be.
Yeah, I can get that one. So we're trying to, like I said, main goal of this course is to get you to a point that you can be effective and useful on your own, meaning you can read papers or read books and pick up the new models and things like this. So that requires sort of 2 things, and also understanding of if a new model comes along, what are the implications of different choices and things. So we want you to have a very intuitive understanding, and that's really what analysis and theory is for. And so part of the homework, there will be analysis questions where you will be doing, deriving this. For the most part, you'll be walked through step by step, but there will be some amount of mathematical computation. You could call these proofs. There's never going to be here's a theorem statement, prove this, and it with no guidance at all. We're trying to. The goal of the homework is to teach. The goal is not busy work, and so we're trying to guide you to the solution, because the actual solution is what we want you to take away from it. But we want you to get those skills and that understanding. What are the concepts that are necessary to get to that resolution? That's what we're trying to teach with that. So, but also we want you to be effective. So we need you to be able to program. We want you to actually implement these methods. We want you to actually work with real data and use them. And so we will have, I try to have, well, every homework will have both an analysis component and a programming component. And honestly, I'm very hesitant to say like 50% is analysis, 50% is programming. That might be true for me, but in my experience, students from say applied math, they find that the analysis questions are a joke and they fly through them and it takes them half an hour, but then the programming might take them 10 hours or something to get through the homework assignment. And then your science majors, it might be the complete opposite. So like it's just really based on your background. What are you used to doing? And I really do find that different students have a harder time with different parts. And that's really what office hours is for and section is for, to get that one-on-one time to help you out through the homework.
Yep. Are there other questions, or should we? My chat window disappeared. There we go. Okay, so there will be lots and lots of time for logistical questions at the end. So maybe we'll hold logistical questions. We'll start going through at the end. Okay, so if we want to talk about which course, right? So Kevin mentioned at the beginning, it might be a little confusing to you that you signed up for X46 and you are seeing X46 cross Y46, right? 4 and 546. So 446 is the undergraduate version of machine learning. 546 is a graduate version of machine learning. This is an attempt to do them together. This was an attempt that was planned prior to all of the recent changes we've been adapting to. So that presents a whole new set of interesting opportunities and challenges. But the plan and the difference is that there are basically shared lectures, right? And the primary difference, well, there will be two primary differences. One of which we'll outline here, is in the homeworks. So the grading is entirely 100% based on homeworks for this class. We'll get to in a minute. And 446 will only be expected to do type A problems, right? So on the homework, all of the problems will be assigned one of two types, either type A or type B. Everyone should do type A. And in 446, the expectation is that you will do the type A problems and work hard on the type A problems and do well on the type A problems. 546 is the graduate version of this course, okay? And in that course, there will be both type A and type B problems, right? And the idea for this is that we want people who want to do research in machine learning and really learn a lot about machine learning for their research should do both type A and type B problems, right? We will curve and grade the graduate version so that if anyone in the graduate version wants this to be more introductory, less about learning how to apply this, sort of really getting a deep understanding that they could use at sort of a research level, doing only the type A problems and doing them perfectly will get you a 3.8, okay? If you were in 546 and you want larger than a 3.8, a better than 3.8 grade, you need to do some B problems, right? All right, go ahead.
Yeah, I'll just repeat what Jamie said, just so it's really sort of, first of all, I know this policy may sound very confusing at first. If you go to the website, there is a table about what is in 546, what is in 446, how is it graded, and also a frequently asked questions that I try to sort of run down what possible questions people might have. But basically, at a very high level, if you are enrolled in 446, you should just do the A problems on the homework. Doing the B problems is not going to raise your grade. We will still look at it. And so if you happen to do very well on these problems, I'm not going to say it's officially going to raise your grade, like extra credit or anything like that, but it may like put you in our good graces. Whereas if you're just on that border of, you know, a 3.9, but
you've been muted, Kevin, somehow. Okay.
That's an interesting feature. So if you're right on the border of a grade, we might bump you up. But the expectation is that if you are enrolled in 446, you will not do the B problems. You will only do the A problems. And you will only be graded against those registered for 446. Okay? You are curved relative to your peers in 446. Okay, so if you're in 446, just do the A problems and don't worry about the B problems, and that's how you'll be graded. If you're in 546, if you do the A problems and totally ignore the B problems, you will be graded against your peers in 546. You'll be curved on the A problems, and so you'll be curved just as you would as if it was on a 4.0 scale. Just think of it, instead of giving it on a 4.0 scale, you're curved on a 3.8 scale. But it is also, we are very sensitive to the fact that for many graduate students, a grade below 3.4 does not count. We're very aware of that, and we are basically very cognizant of the fact that anything below that we'll be very, very careful about, and we will attempt to give you something above a 3.4 if at all possible. And so the difference is, why would you ever do the B problems if you can get up to 3.8? Well, if you're thinking that, that's probably, you're not the student that's targeting the B problems. A student that wants to take the B problems is that student that wants to basically get maybe a letter of recommendation, or they want to get that job at Google, or they want to do research, go to grad school, something like this, or they want to sort of stand out to their advisor. That's the reason why you would do the B problems. And because it basically differentiates you, and so you look a little bit better than your peers. And again, you're graded against your peers taking 546 on the B problems.
I also just see a question that's very related to the one you just answered for yourself in chat. Since homework is designed for learning, I don't care about grading. Is there an advantage to doing B problems, right? Yes, there will be new and interesting material. It will be asking you to hone different skills to sort of delve deeper into your understanding of some of the fundamentals that we're talking about. So like, they should be fun if you are excited to learn more. And so you will learn new stuff by doing the B problems if you choose to do them.
I would recommend them. I think that would be the more fun problems. And finally, one question that you may be wondering if you are enrolled in 446 is if you can jump up to 546. This is a very common thing for ambitious students that are wanting to go to graduate school. So if you're an undergraduate in 446 and you intend to go to graduate school for machine learning or a related field, as a professor that looks at lots of applications, I would suggest, and you have time to do it, I would suggest that you bump up to 546 so that so it looks on your transcript that you took a grad level machine learning course. That is my recommendation to you. It's very common for undergraduates to do this. And I would, if you want to do this, you should contact the CSE advisors directly. Do not contact the instructors. We do not have ad codes. The CSE advisors are expecting you, and they have a process in place to bump you up from 446 to 546. And anyone can do this. You don't need to be a major or anything. Okay, and so we'll talk about, I'm seeing some stuff on Canvas and section. We're going to get to that in just a moment. I guess I'll do this one. So there's 5 homeworks. Homework 0, which is due on Wednesday. We call it homework 0 because we don't consider it it has nothing to do with machine learning. It's really just about math and prereqs.
But it is required and great.
It is required, yes. It's not optional. And then homeworks 1 through 5 are those that are actually, machine learning homeworks. And they will all include both theory or analysis and programming. Collaboration is okay. It is okay and encouraged for you to talk to your peers and perhaps, work through the problems. Basically, what I encourage you to do is you have your own piece of paper, you're working through the problems and talking about them. and talking about concepts and talking about like how do you get from one place to another. If you ever find yourself copying and pasting something into a window, that's where you've gone over the line. You should never be
one place where you've gone over the line.
What was that?
That's at least one place where you've definitely gone over the line.
Yes, yes. You should never be copying and pasting like LaTeX to someone or code. That will be checked for, and we will not. We are just very serious about this. And by the way, we also use homework problems from previous years. Please do not Google for answers. Please do not Google for Stack Overflow.
Please do not ask former students for their homework solutions.
Yeah, and please don't go to the TAs asking like, what a good thing to do is go to a TA is like, look, I'm trying to get started on this one. I've thought about this is the approaches that I started. These are the places in the book that I've read. A bad way to go to office hours is saying, I don't know how to do this one. So come prepared. But you can collaborate with other folks, but just don't cheat, because we're really gonna have a strict policy on this, because honestly, it's the only thing you're being graded on this quarter. There is no exam, there is no project, and so there's no attendance. So we really just hope you take this very seriously, and we are certainly taking it very seriously.
Yeah, just to that end, we're going to be a little bit more specific and really hound on the next slide, which is, Kevin, can you forward the slide? Thanks. Okay, so we have a very clear, we have a very strong honor code that we're expecting from you this term, all terms really, but this term in particular, because there are no homeworks, there are no ways for us to evaluate you in a closed environment, right? Homework is the only way we're grading you, and so we really expect you to take this seriously, and we certainly will. Okay, collaboration is okay. Don't Google for answers. Don't share code. Don't share a LaTeX source. Cite every collaborator you interact with for a homework. You don't get knocked down in terms of your grade if you mention that you work with 16 people on your homework, right? Cite every source you look at that has anything to do with any of your homework problems. And again, that won't lower your grade by saying you happened upon something when you were trying to just like learn more about linear models. You came upon something that happened to be very related to like a homework problem. We're not telling you that you've broken the rules by doing that. We are telling you you've broken the rules if you have that information and don't tell us where you found it, okay? Do not write up your code or homeworks together, right? You can have meetings where you talk about ideas and sort of how you go about solving problems, but don't sit down and like talk about the phrasing you're going to be using or talk about the precise for loop that you're going to be writing in Python. That's not okay. Word for word, line by line similarities will be checked for. They will not be tolerated in any way or form, right? We have automated ways to check for that stuff. And even no matter how many times this is harped on in these classes, like the number of, like historically, there are always like, 5 to 20 people who do really obvious versions of this, right? Who like copy and paste, and we check for that, and we find it every time. So don't do it. Don't do it. This is like, I'm generally like probably the softie of the two of us, but I hate cheating. I absolutely hate cheating, and I have no patience, no tolerance at all. Okay, so we check for it. We will take action when we find it, if we find it. Okay, so what that means is on the first assignment, if we have evidence that you have word for word or line by line similarity to someone else, you'll get a 0% on that assignment. And that's a big deal when there are only 5 assignments and no exams. And the next time, there will be more serious consequences. Okay? So just be really clear. Anyone you talk to about the homework, write their name at the top of your homework. We'll put that in the LaTeX source, right? So that you can just like, it's an easy field for you to fill out.
Who you collaborate with it will not detract points. It can really only save you points, because if you see an extremely similar solution that's wrong, that's usually how you catch it, is if like someone screwed up in a very weird way. and then multiple people screwed up in the exact same way, that is, and if none of you cited each other, it's very clear that you worked with each other. So when in doubt, cite both the people you worked with and the sources that you got stuff. Like, we are giving you lots of textbooks. There's one official textbook, but which we'll get to in a moment, but there's lots of available resources, and there's lots of amazing resources online. We are not discouraging you from using the online resources available to you, anything to do with the internet, right? Like, and you can search for anything, and you can use those resources. We encourage it. We just encourage you to cite your sources.
Don't Google trying explicitly looking for solutions to the problems, or like, very near neighbors, right? That's like against the moral of this as well, right? Also, Stack Exchange is not where you're supposed to go for answers, right? You can go to office hours, you can come to us, you can talk to each other. Don't use like online sites where, they'll give you arbitrary amounts of information about homework problems, okay?
Unless you're learning how to do a specific like Python operation or something.
That's fine. Or like, how do I get LaTeX to do whatever, right? I'm having whatever weird LaTeX problem. That's fine, right? But like conceptual questions, that's not okay.
Yeah.
So we've harped on this for at least 5 minutes. I don't want to think about how much money you all have spent to hear us harp on it for 5 minutes. Let's hope and like let's say this is the last time any of us on this call ever has to talk about cheating for the rest of the quarter. Great, good.
I like it. Okay, it appears that we are repeating ourselves many times. So homework 0 is due next Wednesday. It is a short review. Please work individually on this one. This should really be a test of your own skills. Homework 1, 2, 3, 4, you can collaborate as we've been talking about. These are not easy and they are not short. Please start early. We will be using Gradescope to submit all homework. Of course, this is probably old hat to all of you. You'll be submitting PDFs of your homework. Your code will be inside the PDF. There's a package on the website that very easily just takes Python code and puts it into a very nice formatted LaTeX text. We expect you to turn in your Python code in that PDF. So all your homework will be submitted as a single PDF file, which will include all your mathematical derivations and all of your code and all of the plots associated with that code. Okay. We will have 3 late days throughout the quarter. You can use these at any point. They round up, meaning if your work is 36 hours late, that is 2 late days. Once you are over those late days, you will get 0%. Use these wisely.
That's 2 late days.
Yes. Use these wisely. Of course, there are extreme circumstances that, for health reasons or things like this, and you should contact the instructors about that. But aside from that, we expect you to follow these 3 late days. Thank you. These will not be extended. These will not be added. We have 3 late days.
Yep.
All code in Python, all written work in LaTeX. And like Python is just familiar. So like the reason why Python is that we will be given sort of like NumPy starter code sometimes, and that's just why. It's just, I don't really care if you want to use Julia or R or any of this stuff. If that makes you happier, you can. That's not a big deal to me. It's just like we will be using Python in lecture sometimes in section, and I just would strongly encourage you to use Python just to be able to follow along. But this is not a programming course. We do not care about style. We do not care about what language you're using. We care about if you are able to finish the problems.
Yeah. So in general, we are living in an age where we are planning actually to do virtually all of this anyway. But there are many different platforms which we're using to run this course, hopefully as effectively for you as possible, right? So a vast majority of the communication we'll have beyond lecture discussion and office hours will be on Piazza, okay? So don't email us with any of us, TAs or instructors, with questions about course material. It's much easier for us to answer you quickly if we all see it on Piazza, right? So that allows other students to answer your question or say, hey, I also have this question. It allows all of the TAs and instructors to simultaneously be able to see what questions are being asked. None of us is awake 24/7, and so you'll get an answer to your question more quickly if you ask it on Piazza. The code for that is on Canvas. You also should have received an email with the link. You'll still need the code in Canvas. Questions about class or homework help, announcements. Section may also announce things, but everything, all official announcements will be made on Piazza. Piazza is not optional. There will be announcements made on Piazza that are not necessarily made on the course page. We will not be using Canvas to make general purpose announcements. That stuff will happen in Piazza. Right? Piazza is your primary communication source with the course and the course material. Yeah, thanks, Josh. GradeScope is where we're doing all of the homework submission and grading. If you have regrade requests, that can go directly into GradeScope. If you have personal concerns, right, of which there are always some, and this quarter there may be many, right, feel free to email this mailing address. It's going to be a more effective way, again, to get to all of us. This includes questions about not regrading, but like personal grades, health concerns, family emergencies, things of that type. Also, if there are technical difficulties that you're having that are sort of specific to you, as opposed to about the platforms being, somehow funky generally, send an email to that email address, and we'll try to find a working solution for you. We know everybody has sort of different platforms and needs and slightly different environments this term, and we can't expect you to all have like UW level connectivity. So please get in touch with us if there are technical problems you have there. There's also the ability for you to provide us anonymous feedback on the website. And side note, please feel free to use that. We'd like that if we get it. We won't be able to respond to you if you give us anonymous feedback, because it is anonymous and we won't be able to respond to that.
We will also be sending out some feedback or like Google Forms to this is the virtual. It's the first time we've done this course virtually. So we'll be sending out some questionnaires to see what works best for you guys, how we can improve, because we're all doing it for the first time here.
Right, and hopefully this is the only time, but
yeah,
to be determined.
Office hours, we have 13 TAs, which is great.
I think.
Was it?
I think we now have 17, don't we?
We have a lot of TAs. They're being added by the day, which means this is going to be a very well-supported course. We're going to have office hours every day. We're going to have section. We're going to have lots of support. And this is so that we can make this course as effective as possible. And again, this is something that you should tell us in feedback if there's anything wrong with office hours, or how we can improve them. I would really we would like to know about that so we can correct that as soon as possible. Office hours are not recorded. So, feel free to, don't ever share private information, but just have your mind at ease, I guess. You can ask the questions that you're embarrassed to ask because they are not recorded. Because we have A problems and B problems, there's a lot of people in this course that don't care about the B problems. So the first half hour of office hours will be reserved for A problems only, unless it's dead. I mean, if no one's there, then you can ask a B problem. But we're trying to reserve the first half hour for A problems only.
Everyone has to answer the A problems, and only some fraction of the class is responsible for B problems.
And in the second half, you can ask A or B problems. So I imagine that this is not actually going to be an issue, but we just wanted to have some dedicated amount of time where you don't want the office hours being clogged with just B problems. And so this is how we've done it. And again, this is one of those things that we could change over the course. If there's too much time allocated the B problems, we can allocate specific TAs for B problems and A problems, and this is a work in progress. We're trying to make it as flexible for everyone as possible.
Yep. Okay, so there have been some questions, and we've pushed them off a bit because we do have a slide about section. So section, which if you're enrolled in 446, you have already been assigned to a section. Section is only intended for 446 students, right? This is one of the other differences between 446 and 546. Again, section is not recorded, right? So feel free to go there and ask questions that you don't feel comfortable asking because something's recorded or because there are 226 participants in a call. You should feel comfortable to ask us questions too, and these will only be posted internally, but we understand that you may feel more comfortable asking questions in a smaller format. That is one of the purposes of section. So please feel free to ask questions there. Also, we're trying to very much encourage you to go to section and participate in section. And one of the ways we're going to try to convince you that that's a good idea is not to record it, okay? If you're in 546, you're welcome to attend section, but please don't monopolize that time, right? You are there if you want to, if you'd like to learn more about something, you can attend section and sort of watch, but please be a passive participant, right? We're expecting, some of these resources are dedicated for the undergraduate students, and this is one.
And so there's a question in the chat about what is section for? Basically, it's just sort of overview of stuff. It's reviewing concepts and things that were talked about in a lecture, but maybe weren't clear, or just needed extra practice, these sorts of things.
Yeah. In the first, teaching, some of it will be about teaching Python and how to use Jupyter notebooks at the beginning. I think in general, section is going through either things we weren't very good at explaining, or delving into some details that we didn't have time to explain in lecture, that will give a deeper understanding of some concepts too.
Yeah, and all section materials will be posted to the website no matter what. The
materials meaning if there are slides or if there are notes, those will be available, just not the recordings.
That's right.
And yes, it is. I am seeing your question about, is that a different Zoom number? Oh, sorry. Thanks, Josh. Great.
So we will be using the main textbook for this course is a textbook by Kevin Murphy, Machine Learning and Probabilistic Perspective. This text is very comprehensive. It has it covers just about everything, but it covers some things better than others. And that's a nice way of saying that we will be using other textbooks to supplement this resource when it's convenient for us. And so there are other textbooks on the website. They're conveniently mostly free. And so they're in a PDF. You can go and look at them. And really, through these resources, if you're more mathematically inclined, meaning you have some experience in optimization or gradient descent, a lot of the things you'll basically be able to just use this free resource, this Elements of Stat Learning course book, and not even use the machine learning probabilistic perspective. We're not going to assign problems out of it, but these are going to be resources available to you, and we will be assigning required reading out of the Murphy text. That will be basically enough to the background knowledge and what we're basically talking about in lecture. That will be basically the official sort of line that we will support and answer questions about. But we strongly encourage you to check out these other resources. We'll be also posting in lecture, optional reading, and it will be out of these books. And these are mostly free, and we'd encourage you to do that reading if you're interested, if you want to learn a little more, or if you read the required text and you didn't quite get it, if something was unclear or was not explained in a way that really jived with your way of thinking, then you can look at these other optional materials that might explain in a different way. And that's why we give you so many materials, because machine learning is fast moving, but there's also lots of resources out there, and we want to give you as many resources and backup options as possible. But it's totally okay if we don't expect you to go and read everything that we give you. We just want to basically overload you with information that you can pick and choose from. We'd really just encourage you to do the required reading, and it's very demarcated on the website. This is required, and these are like if you want to read some more.
Yep.
With respect to addition to the main text, there's only one addition.
Okay, so I think many of you have
Yeah, so many of you have actually gotten ad codes through these links. If you're on this call, I don't think anyone on this call does not have an ad code. But somehow, if you've managed to get here without an ad code, these are the links to get there. If you have friends that want to get into this course, email either myself, Jamie, or the CSE546. These links. Exactly.
Please send them these links. We prefer that you send it to us, actually. So we're not actually allowed to add anyone to this Zoom call until they've been added to the course, right? So if you are not registered for this course, it is a FERPA violation for us to allow you to attend, right? So this is the reason that if some of your friends are like, oh man, I can't, I wanted to audit this course and they're not giving me a Zoom link. The reason is that we are not allowed to add people to this Zoom call who do not have registration active for this course. And that's unfortunate for us. That's not just us being a pain. We were explicitly told that. So we have to abide by that rule for security and privacy concerns. But yes, we will, we have opened quite liberally the ad code procedure. If you send us an email or someone sends us an email for an ad code, we'll tell them to fill out this petition. So it's like, skip the middleman and just have anyone who needs to fill out that petition, and it will be processed in a timely manner.
All right, we've already gone through Zoom etiquette. The chat seems to be very effective using it. Great job, everyone. Yeah, and so just in the interest of time, I'm going to try to blow through the rest of the slides because we are out of time. Somehow we filled an hour and 20. So this is a good place to end, actually. Teaching this course virtually is new to everyone. It's new to you guys. It's new to Jamie and I. We've never taught a course virtually. So we're going to try our very best. We're going to look for feedback. We're trying to improve the course and make it as seamless as possible. But I can guarantee you that there will be hiccups. There will be times when my mute button goes on for no explicable reason. My audio will drop out. My video will drop out. We will take it step at a time and try to get this to work as seamless as possible, but there will be problems. And so I just really thank you for being patient with us during this process. In that, it also includes, there may be, this Zoom link that you're on right now, with a little bit of luck, we can keep this same link consistent over the entire quarter, but who knows? Something could happen and we might need to send you a different Zoom link.
And we'll try to make it correctly in Canvas for you if that happens.
Yeah, and so just just be aware, things are constantly changing. We're going to try to be as consistent as possible. And so I think that's right. Just a last slide on privacy. Really emphasize: do not talk about grades, personal health, or family emergencies on Piazza or anywhere public, not in section, not in office hours. Email the instructors directly for anything personal. Anything class related should go to Piazza. Do not email the instructors class content questions. Lecture is recorded and not public. Office hours are not recorded. Section is not recorded. Okay, and that's all we have for today. I'm sure Jamie and I are going to stick around for a little while and answer any questions, but we want to let people get to their next course if they need to go. And so, welcome.
And somebody asked a question just below. Chat history does not get saved, is my understanding. Okay, so we're going to stick around.
we're also experimenting with this. How do we simulate this? People coming up to the front of the room after class. Yeah, we're trying things out. So on this first day, we're trying out just ending the course and then sticking around and letting you ask questions. And so please fire away, and we'll try to answer as we go.
Yeah, and we'd love it if the people who do stick around, if you have a couple minutes, use type hand because we'd love to actually see your faces and hear your voices as opposed to just instant messaging with you. So
yeah, we do feel very disconnected from you right now.
Yeah.
It's sad.
We thought this might take a lot less time and actually had a small get to know you thing that we were going to do. But. Whoa. Can people ask questions with hand as opposed to in text format at this point?
Hi, Youngkyu?
Call on people?
Is it Youngkyu or Youngkyu?
Oh, how do we unmute you? We want, okay, so I see a hand, but then, okay. So general thing we're hoping for is when you type hand, if we say your first name, hopefully there's not too much overlap in first name, would you unmute yourself and show yourself? Anyway, okay, can we use private Piazza posts instead of email? I think we prefer for.
That's an explicit no. Do not put anything personal or private on Piazza.
Piazza is not owned by the University of Washington.
Right. It is not. I don't believe it's FERPA compliant. So you have to, if anything is not course related, you cannot just privately message us. You have to email us.
Yeah. Shot? Sorry, say again? We can see you.
Can you hear me?
It sounds a little bit like you're Darth Vader, but I can sort of.
Yeah, can you hear me now?
Yes.
Okay, so I just want to ask, there are so many algorithms like random forest or gradient boosted trees and all of that. So are you going to cover the mathematics behind those algorithms, like how are they overfitting and things like that?
So our intention later in class is to talk about boosting. We will be talking about overfitting as a thread throughout the course. I think when you're saying random forests, so historically, I think we have talked about boosting on small decision trees and things. We are more interested in teaching you concepts about how you would go about trying to decide if a class of models is the right class of models to be using for the problem you're solving, as opposed to promising that we're going to teach you how to program up some solution using random forests and decision trees.
Okay.
We'll probably get to boosting. That is something that we are intending to cover.
Okay. Thank you.
Yeah, short answer, we'll talk about it, but not in great depth.
Okay.
Ani?
Hi, yeah. So should the readings be done before or after lecture?
Ideally, I think we have to, ideally before.
Okay.
Yeah.
Thanks.
So during,
okay.
sorry, I was just gonna say, reading these questions. When we post a lecture, like lecture 1, lecture 2, required reading, and then the lecture slides. And so yeah, readings will be assigned with lecture, so you know what goes with what.
Yeah.
And a complete syllabus? No, we don't have a complete syllabus. We don't, again, we don't know how virtually is going to go. For instance, this course, this time took 1 hour and 20 minutes. In years past, this period has not taken this long. So we just don't know how fast we're going to go. So it'd be impossible to post a complete syllabus at this time. However, I encourage you to look at previous years, in particular previous years where I have taught. So if you just change the website from 20 SP to 19 SP, that will be a pretty good indication of what we intend to cover.
Yep. Dino.
Yeah, I just have a question. Which of the platforms, actually I have a couple of questions. Which of the platforms are intended for student collaboration? Because it's a slight bit of difference. Let's say, a lot of students here are CS department, but there are some that are not, and looking for help within the department might not be, fruitful. And then I also have a question about the content, how to ask for help to not break any of the rules. Let's say I have a question, I did some work, I post a PDF with some LaTeX equations in it, how far I got, looking for a hint on what I should do next or what assumption I'm missing. I can't stop people, let's say, that didn't get that far seeing that. I don't know how to handle that in context of collaboration versus, what we discussed about what you consider cheating.
So I would recommend not posting partial solutions to Piazza as step one. I think office hours are a great place to ask. If you've gotten into the weeds in a certain way, or like that's one thing. We're going to have office hours mornings and evenings every day of the week. So it won't. If you've made some significant progress and you have like a technical question that like really requires you ask, including a big part of a solution to a problem, it may be more appropriate to ask that question in office hours rather than on Piazza. You can also, I don't know, there are private Piazza posts?
I don't know about that, but one thing that I guess I use your judgment of what would be appropriate for Piazza. If it's over the line, we will correct and we will delete the post. But stay cautioned. Also, I would discourage posting like PDFs, because that again, this is kind of like if you find yourself copying and pasting large chunks of things, like that's the line. But Piazza does allow you to type in LaTeX. You can type $, and then some math, and so like, you still can put equations on Piazza. It's quite nice. And so you're welcome to do that and talk in math and, hey, how did this derivation work again in class? That's totally appropriate. Now, when you mention like how are we supposed to collaborate, what kind of platforms? That's a great question. I think we should brainstorm on that. One potential idea is to have rooms set up, Zoom rooms, perhaps. There are sort of breakout rooms possible, and maybe we can have just sort of like a homework Zoom room maybe sometime, or just post on Piazza, just like, hey, I'm going to be hanging out in this room at 3 p.m. and talking about homework problem 5. I'm struggling, and maybe if we all work together on it, we get somewhere. So we'd encourage that kind of behavior on Piazza of like, hey, let's meet on Zoom to talk this out.
And we can't, if I could, I would just post a link to a Zoom room that anyone could use at any time to like check in and see if someone was in there for homework. I don't actually know how to do that in such a way that I am not the host. And I would rather not be the host of that for a variety of both technical and pedagogical reasons. So, I think posting on Piazza, like, hey, does anyone want to chat about some homework? Here's a link, I'll be here for the next hour, is like, that might be one way. We're very interested in you guys experimenting with other things and letting us know if particular things work well or badly.
All right. I mean, just as a common sake, it kind of feels like there's no real way to collaborate with students that you don't know, short of, I guess, like that's my comment. I don't feel you encourage student collaboration, but I don't see a good way to do that without breaking some rules, I guess, is what I wanted to say.
So there's a difference, right? I can talk about the homework and we can work through the homework. It's kind of like, let's say you're in a Zoom room and we're trying to meet, get from one line to the next, and you're saying, well, how can we do this? You're discussing it, and like, oh, what if we tried this? And then maybe like, okay, like basically everyone in that room heard that, like, oh, what if we tried this? Oh, it worked. And then like, now I'm going to describe like how that worked. So if you're describing in math, basically in words, how working through a problem and getting from one line to the next, that's totally fine. That's like very different, because that's like basically helping people out and having some sort of give and take. and this sort of naturally is good for collaboration and doesn't go to the point of cheating, because if there's one person in a room just giving out the answers, that person really has little incentive to be there. They just don't show up. And so typically the people that stay in a room are like everyone's sort of giving and taking, and working together like that. And so and talking through the solutions that way is totally fine. It's the line is where you start copying and pasting entire chunks of code into the chat.
And also, I think we want to encourage people to, you can write something. If you could do it on a whiteboard, it's also probably fine. So like, feel free to like write some stuff down on this, or even like on a piece and hold it up to your camera and say like, hey, this is where I am and this is what's confusing me from here to here, right? Not that this is like anything sensical to you guys. This is just some random notes. But like, feel free to do that. This is something that sort of says like, here's the technical problem I have. And there are various other ways to do this too, right? There are ways to take pictures and like share them and what have you. But this also doesn't, I think this allows you to say like, I don't know you particularly well, but I have this question, right?
And like a good way of doing this, if you're finding collaborators, could really be just like posting on Piazza, saying, hey guys, I'm working on a homework problem, 8.3, and I'll be on Zoom channel, post your Zoom link. I'm going to be on here for the next hour. Join if you, want to talk it over. I'm working through it now. That's totally cool.
Mm-hmm. Yeah, and if you, as is being said in the chat here, right, like Zoom has a whiteboard feature. So like if you have a tablet, that's a great resource. We're not expecting you to have one. So like, old fashioned plus new fashioned, like still can be reasonably effective. Okay, let's see. Are there other hands? There are probably lots of hands. Okay, so let's see. Baraj?
Yeah. So one thing that I was thinking is like in the past iterations, like there were projects for this class, and so like say that again.
For 546.
Yeah, for 546, I was like, yeah. So like, what is your rationale for kind of like not including the project? Do you just think it'd be too hard, kind of like to have collaborations because of this?
Yeah, so I run this course with the project and without the project. I'd say it's very bipolar, or there's very bimodal sort of outcomes with the project.
Right.
For a small portion of students in the class, the project is amazing. They get to learn, they get to use their, work on their research, or really push some idea of theirs that they have. And it works out really well. And I've seen a number of those projects turn into conference publications.
Oh, wow, okay.
But those are by far a rare thing. The vast majority of the time, the students, we have 10 weeks, right? Mm-hmm. So the vast majority of the time, the students have to choose their project too far in advance, and really before they know any of the techniques. And so they're committing to this thing. They either don't really know what they're getting themselves into, or they are picking something that they actually don't care about. They actually want to do something else later in the quarter. And for the vast majority of people, and I've gotten a lot of feedback on this. Well, is amazing for a small group of people. For the larger group of people, it tends to be a lot of work, and not actually that you're not really learning all that much more. And in the feedback I've gotten, they have really said, I think actually spending more time on homework problems, I would have learned more, because I could have seen more, rather than getting really focused on something that I actually don't really care about because I chose it in week 4 before I really knew anything.
And if there's something you're super jazzed about as far as like a project involving machine learning, like you're certainly welcome to, like, if there's nobody else in an office hour, ask questions about it. But just in general, if we have 200 people taking the class doing a project, we can't even provide meaningful feedback to that anyway, right? In a way that would like actually help most of the projects.
Right.
I see. Sorry.
I was just go ahead.
We will. So, but what is lost in the project, not having a project, is not having that sort of deep dive on a particular subject, not just like following the steps in a homework problem. And so the last homework assignment is basically taking the gloves off and saying like, look, you've learned about all these techniques. You can use deep learning. You can use gradient boosting trees. You can use whatever you want. I just want you to hit this accuracy, or I want you to achieve this, or I want you to think a little bit about this. And so we are trying to, more than other quarters, try to have more of a project component to that last homework that will allow you to go a little deeper in one particular sort of area of your choice.
So normally, like the projects that people have done, is it like normally more application rather than like theory? Like you're not proving some bound for X, Y, Z. Is that not the flavor that you normally see with projects?
Typically, yes. All the theoretical problems that people have done in the past have not panned out. It's basically been, we tried to do this, but we didn't get it. The project is mostly about, here are the things we tried that didn't work. Yeah, I typically encourage more empirical and applied work.
I see. So you were thinking of, so this whole like transition to not having a project was like, this was more out of the feedback rather than this online setting. You were just thinking about not doing it.
Yeah,
anyway.
It was a decision we made in January.
I see. Can I ask one more question? Yeah. So like, what is the difference between like, so there's like this course of machine learning versus like statistical learning? What is the demarcation line between like these two things?
Yeah, I mean, Jamie can answer that. I'll give you my quick answer. Honestly, I consider them to be very closely related. I think that there's, why is machine learning or data science not in a statistics department? It's not very clear. Perhaps because in computer science we do more computation, and machine learning is this beautiful marriage of computation and statistics. But the difference between machine learning and statistical machine learning, I use these terms pretty synonymously. But I think what you're getting at is, what's the difference between machine learning and statistical learning theory, which is the course offered in other departments. Electrical engineering has statistical learning theory, I think, very rarely offered, I think. And we're trying to offer more courses like that. But machine learning, this course is more about fundamentals, about trying to get you to understand the how things work, what are the more computational and the applied side of things, as well as the analysis side of things. Whereas statistical learning theory is really trying to prove things. It's trying to say, like, what is learnable? What does it mean? How well does this algorithm work?
Estimator things like this, right? So like, and in general, computer scientists sort of have their own bent on things, right? Like, we generally care a lot about like whether we can actually compute something, whether with 16 samples, what can we say precisely about like how well something's going to work, right? Stats department,
like empirically, or like when you say like like empirically, can you say something with 16 samples? Is that what you mean?
No, I mean I also mean theoretically speaking.
Okay.
Right? Like, statistics, historically, this is maybe a little less true like in the last 20 years or something, but historically statistics only cared about limiting behavior, right? They're now caring more about rates in the last like 20 years or so, but like computer scientists have always cared a little bit more about the rate side of machine learning, right? Sort of precisely how quickly things converge, right?
Right.
And that matters a lot if you're actually like applying stuff, not just sort of understanding what's happening sort of theoretically as your sample size grows very large. Also, like in many places, here included, many places have machine learning, statistical machine learning, and machine learning theory, all three. And sometimes all three are required for a given degree, right? There is overlap. I think as much as anything, it's a difference in perspective. They will cover, related things, but we're not going to spend like, 3 lectures talking about shattering dimension in this class. You might do that in statistical theory, or at least 1 lecture.
Got you. Okay, cool. Thank you.
Yeah. Okay, so there are other questions. C. Chang, are you still here?
Yes, I'm still here. Can you hear me?
Yes.
Okay, cool. So I got 2 questions. The first question is, I'm a student outside the CSE department, but if I want to use the course machine for course VM for the 546 for the programming part, like could I like apply for a temporary CSE account?
We're working on that. So
okay.
So we only have machines that we're really planning. We're expecting that like a basic laptop should be sufficient for all of the assignments. The last assignment, we understand some people really want to like throw some heavy GPUs at, although we can like we have found that we are capable of beating all of you on our personal machines.
Okay.
So like we will have some machines available. So far, they're only going to be available for CSE accounts, but we're working on a workaround.
Okay, cool. And the second question is like, because I have already taken several like other machine learning courses in UW, like CSE547 or the Biostat 546. Like if by any chance, like I get the same homework problem or the similar homework problem, can I use the solution like I did before directly for the course?
Sure.
Okay. Cool. That's all I got. Thanks.
Yeah. Okay. Cool. I'm looking for the next hand. There are specific. Okay. Let's see. I don't see any other hands. The rest of the questions seem to be questions about various other things. Okay. So does anyone else want to ask any questions aloud? I think a bunch of the questions in text have been answered.